Okay, thanks very much. So this will be the final actual talk that's a bit like this, where someone's standing in front of you and you're just listening. So hooray for that. And then we'll be getting on with the demos after this talk. But I just wanted, before we do that, I just wanted to talk to you about a couple of tools we've developed at the University of Reading, particularly around data sharing and visualization. Obviously, there'll be demos of this as the afternoon goes on. The first tool that I want to mention is a tool called, with the snappy title of NCWMS. And for those of you who are familiar with the Open Geospatial Consortium, the OGC standards, and particularly the Web Map Service standard, the Web Map Service standard, or WMS, is a specification for serving map data over the web. So that you tell the server, I want a map of this area at this spatial resolution and this projection, and the server gives you a map. And what we did, in fact, this was a project that started several years ago, was create an implementation of the Web Map Service specification for multidimensional scientific data, such as ocean forecasts, weather forecasts, climate data, which are not just about maps at the surface, but also about information that's down beneath the surface and above the surface, and slices through that information, in other words, a kind of data cube kind of view of the world. And the primary format in which that data is exchanged is a format called NetCDF, so hence NCWMS, that's where that comes from. And so we've made this available for a number of years, and we enhanced it during the Melodies project. And one of the main uses for this is not only to interact with GIS systems to provide a bridge between NetCDF data and GIS systems, but also people use it even within the scientific community just as a quick look onto the data. So lots of institutions put up these NCWMS servers, and then people can just quickly browse through the data in multiple dimensions and have a look at even their own data or other people's data. And one of the things we did during the Melodies project is modularize this much more strongly than it was before, so that we've been able to take the libraries and the guts of this system out and use it in other projects. This is just a screenshot of what the interface can look like. One of the things that we did within the Melodies project was add the capability to visualize categorical data, such as the Melodies land cover data. Previously, NCWMS could only visualize continuous value data like temperature or salinity or wind speed or something like that. But now it will understand categorical data. The idea is that the NetCDF files contain all the configuration you need. They already have rich metadata inside them, and that's automatically detected by the system, and effectively the system self-configures so that it will serve out the data with minimal configuration on the user's part. That sort of, oh sorry, I'm pressing the wrong buttons here. That client you're seeing is what we call the Godiva 3 client, because it's the third version of the Godiva client. We're really good at naming. And what that's doing is taking advantage of some enhancements we've made to the Web Map Service standard. So Web Map Service is mainly about the maps. We've allowed people to take different slices through the data, do things like have greater control over the color palettes and the color scale ranges, create animations, export into various formats. And Godiva is a special Web Map Service client that allows you to take advantage of those extensions. So Guy, who's over there sitting obediently by his poster over there, will be the one who can take you through all of this. Another innovation we developed in the Melodies project was the ability to visualize data that is recorded on what we call unstructured meshes. And this was actually inspired and driven by our interactions with Work Package 10 and Francisco and Javi, who have their groundwater model data is produced on these unstructured meshes, which are essentially triangle-based meshes rather than nice, well-behaved square grids. And so that provides a particular challenge, but again, it's possible to record all that metadata within the NetCDF file using standards called, what they call the UGrid standards. Is that right, Guy? The UGrid standards, which are an emerging standard for unstructured mesh data. And now our Web Map Service product can understand that and serve out the maps in whatever well-behaved geographical projection you would like. So you can't really tell here because the whole point of it is to hide the complexity, but this is a data of current velocities around the northwest Iberian Peninsula, and the underlying data are are recorded on this kind of triangle mesh, which you can see a little bit better in this garish screenshot here. But what we have is today, Guy will be available to demonstrate what this system can do more from the user perspective, and tomorrow in the hands-on workshop there'll be opportunity to install this for yourself and configure it with some example data, and hopefully you'll find that's quite easy to do. The second tool I want to talk about is it's not so much a tool, but it's a format and tools around it that's been developed by Maik Riechert, is he there? Oh, you're over there. You're over there. So that's somebody else's legs over there in that case. So Mike's legs are over there and he's over there. And it's a format called CovJSON or coverage JSON. This is the idea behind this is to make it easier for people to develop web portals and mobile apps that consume multidimensional scientific data. And now, as I've mentioned, these data comes normally out of data repositories in forms like NetCDF, HDF, and GRIB, GeoTIFF, and web developers just aren't familiar with these kind of standards, and they're not very easily parsed within a web browser environment. There's not very many JavaScript libraries for this kind of thing. These formats are really designed for archival of data and server-side data processing, that sort of thing. As a result, when we build apps, we often build them out of images rather than real data. But actually now the web browser is a really powerful analysis environment in its own right. JavaScript and HTML5 have evolved to the point where you can do really sophisticated things on your mobile device, in your web browser, or on a laptop. And so what we're trying to do is provide a format that would allow that kind of complex multidimensional data to be served into a web browser environment where app developers can do really creative things with it. So we're trying to be lightweight and efficient. We're trying to be easy to understand, easy to produce if you're a data provider, and easy to consume if you're an app developer. But we still retain the features that are present in typical NetCDF and other kind of files. So we have spatial, temporal, and other dimensions. We can deal with gridded and non-gridded data. We can deal with data of arbitrary dimensions, continuous and categorical data. If you have very large data sets, you can split them up into tiles, like Google Maps does when it's serving very large map databases. And you'll see if you talk to Mike and you read the poster that the support for internationalization there too, so that you can, anything human readable that's intended for human readable display can be given in multiple languages. And inbuilt inside this, which most people don't need to know about, but some people will be interested in, there's some support for what's called JSON LD, which is JSON linked data, which is essentially a way of recording linked data or RDF in the JSON format. Now, there's a kind of mismatch between what you can do in that format and what we want to do in coverage JSON because of the support for multidimensional arrays, that kind of thing. But it's possible to at least partially automatically take a coverage JSON, a CovJSON document, and convert it to RDF. And that might afford some interesting possibilities in terms of querying metadata and integrating with other data sources. This is used, amongst other things, in our sample technology demonstrator portal that Mike has been building. And this is the portal where we've been harvesting some samples of data from the various Melodies services. So for some of the Melodies services, you can go into this portal and you can display the data. We've done some conversion into this coverage JSON, CovJSON format. You can bring it together with things like GeoJSON. You can do things like taking a large raster data set, bring that together with a data set of administrative boundaries, for example, and then use the administrative boundaries to subset the raster data set to give you just the area of interest. And that's all done in JavaScript in the demonstrator portal. We can talk to the Melodies catalog via this GeoDcat AP format, which is a catalog format, and Mike can show you all of that too. So with 40 seconds left, so today Mike will be able to show you how it works. So he'll be able to take you through as much technical detail as you like. And tomorrow there'll be an opportunity to create some of your own JSON documents, serve them from a web server, and do some visualization in a web browser. And hopefully, again, you'll find that's not too difficult. And so that's it. Thank you very much.